Finally, we come to the part of this course where we're talking about cracking wpa-PSK and wpa2 PSK. 3 points I want to make here. Firstly, wpa-PSK and wpa2 PSK, why are we grouping these two together? Why not wpa-PSK and wpa Enterprise together, and then later wpa2 PSK and wpa2 Enterprise together? The reason is that the security protocols and exchange of messages are similar for wpa-PSK and wpa2 PSK. So understanding one, we understand the other as well, and we can use the same way to attack the scheme in both cases. The difference is in how the key is used eventually. So the process of key derivation is similar, and then eventually we're using the very powerful AES for encryption with wpa2, whereas we're still using RC4 with WPA. 2 more points, and that has to do with the second part of the title here, which is guessing the passphrase. Why do I write passphrase rather than password or key? Unlike the case of WEP, with WPA, we have the concept of a passphrase, which is then mapped to the actual key, which is a mapping of something which would be typically more human readable, although it doesn't have to be. So passphrase is something that the user would see and then would typically enter into the different devices. And then the key is something that would typically then be seen in hexadecimal or a binary. The guessing part of it is the third point. So why do we say guess the passphrase? And that's because unlike WEP, that's the difference here with wpa-PSK and wpa2 PSK. And that is that we do not have a good way to deduce the passphrase or the key from statistical means. So we have to end up trying to guess it with a kind of brute forcing dictionary attack, which, as you may imagine, is not as effective because it relies on the password being something that's easily guessable. So compared with WEP then, the WEP key would be pre-shared with multiple stations, and is the same for WPA2 and WPA PSK, but there is a difference that this shared secret that is pre-shared with multiple stations is used directly for encryption with WEP, whereas it goes through some kind of key derivation process in WPA PSK and WPA2 PSK. As I mentioned, the passphrase is the thing that's common, but then it goes through a key derivation process so that the pre-shared master key then would be something that the user doesn't see directly. And furthermore, the pre-shared master key itself is not used directly for encryption, but the pairwise master key, PMK, is not used directly for encryption, but it is used to derive a pairwise transient key. And the pairwise transient key is the one that's actually used directly for encryption. So the pairwise transient key is something that would be different for each station. It wouldn't be the same, even though the PMK would be the same because it's the same SSID for all of these stations. With WEP, we can capture enough frames with different IVs and we can find the key, whereas with WPA PSK and WPA2 PSK, we cannot do that. In the case of WEP, due to these many weaknesses, even if the key is hard to guess, it doesn't help to protect the key. Whereas with WPA-PSK and WPA2-PSK, it helps if the passphrase rather is hard to guess. It's not a simple dictionary word or simple combination of dictionary words. The process whereby the PTK is derived is through this exchange of messages known as the four-way handshake. And it turns out that we can capture the four-way handshake and use it to do a brute force attack because of the way that the four-way handshake works, which we will demonstrate shortly. This four-way handshake is meant to confirm the existence of the pre-shared master key at the peer, so both the access point and the station would be trying to confirm that the other side has the same pre-shared master key, which means that it has the same passphrase because the pre-shared master key is derived from the passphrase. And then fresh keys could be used for cryptographic operations if you do this four-way handshake, because you'll be deriving a fresh PTK. Besides peer-to-peer communications, there's also group communications like multicast and broadcast. So the group transient key will also be sent from the authenticator to the supplicant, so from the access point to the station as part of this handshake. And then another purpose is the confirmation of the selection of cipher suites. Inputs to the four-way handshake include the pre-shared master key, which is derived from the passphrase using this PBKDF2, which we will talk about more in the next video, and a couple of nonces. So each side will generate a nonce. The authenticator nonce, or A nonce, and the supplicator nonce, or S nonce, referring to the two sides. Remember that the authenticator is the one that's trying to guard the access to the network. So in this case, the access point, and the supplicant is the one that's requesting to join the network. In this case, the station. As a result of this four-way handshake, we get the pairwise transient key, which is not sent over the air. But at the same time, we also get this MIC, message integrity code, which is sent over the air in messages 2 and 3. So we are going to look at the four-way handshake in more detail in the next video. And we will talk about that, how the passphrase can be guessed if it's easily guessable.